In this video, we're going to evaluate two definite integrals. The first one has limits from 0 to 4, has a radical in the denominator. If you take the derivative of the radicand, x squared plus 9, you get 2x. So that's perfect for a u substitution. So we'll let u equal to x squared plus 9. Then du would equal to the derivative of x squared plus 9 is 2x, and then we have the dx. So the 2x dx will be replaced by du, and the x squared plus 9 will be replaced by u. Now we do have to change the limits of integration because I'm changing the variable. So all we have to do here is say lower limit is x equals 0, upper limit is x equal to 4. So using this substitution here, if we let x equal to the lower limit, x equals 0, that would imply that the u would be 9. And if we let x equal to the upper limit of 4, we need a corresponding value for u. So that would be 4 squared is 16 plus 9 is 25. So now we can start here. This would be the integral. Instead of 0 to 4, it's going to be 9 to 25. Now keep in mind that you can always ignore the limits and do the integration, any kind of substitution you want. But if you go back to the original variable, then you can use the same limits you started off with, 0 to 4. But here I'm going to leave it in terms of u, so I need the limits of integration in terms of u. It'd be 9 and 25. So the 2x dx is replaced by du. And then the x squared plus 9 is replaced by u. So it has the square root of u, or I can write it as u to the 1/2. Again, limits from 9 to 25. And let's bring the u to the 1/2 to the numerator. That becomes u to the negative 1/2 du. And then we integrate here with respect to u. So add 1 to the negative 1/2, and we get u to the 1/2. I'm just going to write the square root here. So add 1 here. It gives me u to the 1/2. I'll write it as square root of u. And then we divide the coefficient by 1/2. That'll give me a 2 out here. The limits here are going to go from 9 to 25. So this will be 2 evaluated at the upper limit, 2 times the square root of 25. And then it's minus 2 times the square root of at the lower limit. This will be 9. And just evaluate this. Square root of 25 is 5 times 2 will be 10. Square root of 9 is 3 times minus 2 is minus 6. 10 minus 6 is equal to 4. So that's the value of the first integral. Evaluate it from 0 to 4. Change the variable in terms of u. Change the limits to 9 to 25. And we got the answer of 4. The next one is going to be evaluated from 0 to 2. And this one doesn't factor. It's a rational expression, but it doesn't factor. So I'm going to complete the square on this one. And I'm going to use this formula right here. Used it before. I can write it in this format here. The integral of du over u squared plus a squared. U will be a function of x usually. A or a squared is going to be a constant. And we use the integration formula involving the arctangent. So there it is. Okay, I'm going to put it in this form. I can use the u substitution and change the limits of integration, but we're going to do it this way. I'm going to write the denominator as x minus 1 quantity squared. So notice, if I square this out, x minus 1 times x minus 1, I'll get x squared, which is right there, double the product, minus 2x. Minus 1 squared is 1. I got 2 here, so that means I have to add a 1 here. Now that's exactly the same thing. All we did was rewrote the denominator as a sum of squares. And this is where we call it completing the square because we completed the square of the x squared minus 2x right there. So notice if I were to let u equal to x minus 1, then du would be dx. It wouldn't change. Now this were a 2 here, 2x minus 1 or 3x minus 1, that'd be different. So in this case, what I'm going to do for this formula right here, the du is just going to be dx. The u squared, that's x minus 1. And then the a squared, right here, 1 can be written as 1 squared. So there we have it. So I can go directly to that formula now. Say this is going to equal 2. Don't have to change the limits of integration here because I didn't write u there. I left it as x minus 1. All I'm going to do then is say, okay, this is going to equal to arc. Can also call it tangent inverse or inverse tangent. Arc tangent. And you look at the formula here, it's u over a. In our case, u is x minus 1. So it's x minus 1 over a. But a is 1 right here. So that's still going to give me x minus 1. And then we just evaluate from 0 to 2. So this will be arctangent. And we evaluated 2. So 2 minus 1 is 2. So the arctangent of 1. And then it's minus arctangent evaluated 0. So it'd be 0 minus 1. Negative 1. And nobody on these, unless it's stated otherwise, you want the answer in radians if it's going to come out to an angle. So arctangent of 1 is pi over 4. You're working with degrees, that would be 45 degrees, but usually we use radians here. And then it's minus arctangent of negative 1. That's negative pi over 4. Double negative there. So we get pi over 4 plus pi over 4 is 2 pi over 4, which reduces to pi over 2. And this one, if you want approximation, you can use your calculator and write the answer to 2 places, 1.57. I'll just leave it in this form here. Thanks for watching. We'll see you next time.